Hi and Assalamualaikum. We are from CS2485B2. We'll be presenting on our topic, which is circle curve vector field by using line integral. Let's meet our team members, which are Aimi Iwani binti Zairul Hisham, Farah Ashikin binti Jumain, Siti Nur Adlina Yusrina binti Nur Azizan.
Assalamualaikum, I am Ainuani binti Zairul Hisham. I will be presenting the introduction of line integral. A line integral is an integral that evaluates the function to be integrated along a curve, which are used to discover area of flats. Two-dimensional surfaces, areas or surfaces that curve out into three dimensions. It is also known as the path of integral, curved integral, or curvilinear integral. Line integral divided into two types, scalar line integral and vector line integral. The diagram shows a line integral that calculates the area of three-dimensional surface. The line integral have various uses, including calculating surface area in three-dimensional planes. The application of line integral in vector calculus is applicable to wire mass calculations. Second, it assists in calculating the moment of inertia and the center of mass of the wire. And last, a line integral is in Faraday's law of magnetic induction to calculate the voltage produced in a loop. We move to the next part, scalar line integral. It is similar to a single variable integral, except that the domain of integration for a scalar line integral is a curve in a plane or space rather than a curve on x-axis, and the integrand is a function of many variables. It follows Theorem 50.1 as the definition of a line integral as it shown above. We go further for the last part of introduction, which is vector line integral. It is the integration of a vector value function along a curve. The work done on the particle is determined by the direction in which the particle moves along the curve. The stated direction is positive along the C, whereas the opposing direction is negative along C. When C is given an orientation, it is referred to as an orientated curve. To calculate the work done by the force, only the portion of the force acting in the same direction as the object must be considered. This means that it should consider the projection f dot t of the force vector F onto the unit tangent vector t at each point on C. The formula shows how work increment on a small sub-arc and the total work done in terms of arc length. That's all for me. Thank you.
This is our question 1, which we need to find the works done on a curve which is given by the upper semicircle x square plus y square equal to 1, given the force field Fxy equal to x plus y vector I plus x vector j.
Hi and Assalamualaikum. My name is Siti Nur Adlina Yusrina. So I will be presenting on mapper command and output for question 1. First, we need to restart the command in the mapper. Then we use with vector calculus since we are going to use dot products. We also use with plots because we are going to plot the field using field plot and the implicit plot. Then here is our force field where Fxy equal to x plus y ex plus x ey, where the ex and ey refers to vector I and vector j. And then field plot used to show the flux movement. Here is the flux movement. The implicit plot is to graph this upper semicircle which is x squared plus y squared equal to 1. Here is the graph of semicircle for this question. We need to find RT for the given curve. After that, we need to differentiate RT with respect to t. Then we need to find the dot product of force field with dr. We need to substitute x and y from the answer of dot product to generate function in terms of t. Lastly, we calculate for work done by integrate the answer from substitution from 0 to pi. And finally, we get the answer where the work done is 0. So next, I'm going to explain for manual calculation for question 1. Firstly, we are going to find RT, hence for upper semicircle equation, x squared plus y squared equal to 1. So we can get the x equal to cos t and y equal to sin t. Therefore, the RT is cos t vector I plus sin t vector j. And the range of t is from 0 to pi because it is a half circle. Then we differentiate the RT, so we can get so the RT will be negative sin t vector I plus cos t vector j. Next, from fxy given, we substitute the x and y into fxy to generate equation ft. Lastly, we do dot product of ft with r prime t and we integrate the answer from 0 to pi. And we will get the answer equal to 0.
I think that's all from me, so I will pass to Farah to continue question 2. For question 2, we need to evaluate the work done where fxy equal to negative y vector I plus 2x plus 1 vector j and c be a curve represented by part of circle where x squared plus y squared equal to 4 from 0, negative 2 to 0, 2.
Assalamualaikum sir, my name is Farah Ashrin binti Jumain. So today I'm going to explain for Maple command question 2 and also the manual calculation. Okay, in Maple, firstly we use restart the command. Then we use a width vector calculus because we are going to use a dot product in the calculation. Next, we put command with plots because we are going to plot the field using field plot and implicit plot. Then we insert the command for equation of force field, which is fxy equal to negative 2y, comma 2x plus 1, where this is for component for vector I and this is for vector j. Okay, when we click the enter, the mapper will show f equal to negative 2y ex, where ex represent for vector I, and plus 2x plus 1 ey, where ey represent for vector j. Okay, and then we do field plot to show the flux movement. Okay, here is the flux movement for this question. Okay, next, we do implicit plot to show graph of curve C, where represented by circle of x squared plus y squared equal to 4 from 0, negative 2 to 0, 2. Okay, then we need to find RT for the given curve. After that, we need to differentiate RT with respect to T. Okay, then we need to find the dot product of force field with dr. We need to substitute x and y into the answer of dot product for generate function in terms of t. Okay, lastly, we calculate work done by integrate the answer from negative pi over 2 to pi over 2. And finally, we get the answer where the work done is 4 plus 8 pi. Next, I am going to explain for manual calculation for question 2. Okay, firstly, we are going to find the RT. Hence, for circle equation x squared plus y squared equal to 4, we can get x equal to 2 cos t and y equal to 2 sin t. Therefore, the RT will be 2 cos ti plus 2 sin tj. And the range of t is from negative pi over 2 to pi over 2 because it is half circle. Okay, then we differentiate RT where it will be negative 2 sin ti plus 2 cos tj. Okay, next from f as y given, we substitute x and y into f as y to generate equation ft. Okay, lastly, we do dot product of ft with r prime t and we integrate the answer from negative pi over 2 to pi over 2. And it will get the answer which is 8 pi plus 4. Okay, that is all from us. Thank you.